of all, I wanted to say that, you guys are all, I'm sure, aware that we're having a test on Wednesday. I have posted this study guide for test 1, and so I thought I would go over that first here before we get into the material for today, just so that we can make sure we talk about it and we I don't forget to go over that. So you can pull this up at any point, and I'll let you do most of the reading. However, there's some things I thought maybe I could point out here if it doesn't take too long. So first of all, the first paragraph, I'm not sure that you're going to feel like this helps you too much, as far as it's not really narrowing down anything. I'm not saying, well, you need to know this, but you don't need to know this. I'm basically saying you need to know everything that we've talked about, to the extent that you could do problems similar to the ones to participation activities and challenge activities that you've done. Okay, so I'm just saying here in this first paragraph to really just go through and study all of the notes and study the zyBooks material and so on, and going through and doing your participation and challenges assignments again would be great, because that gives you practice. And looking back at some of the things we first covered, it seems like so long ago that we covered that, to me. And so I'm sure it kind of seems that way to you too. So anyway, definitely don't plan on remembering all this at this point, but go back and really study it and really try things and go through everything. You won't mess up your points for any of the challenges, so if you've already got points for something, it won't take them away if you like open a challenge and then don't complete at that time. As long as you've done it once and you've gotten your points, that'll be okay. So you're going to want to do that. I do kind of tell you a little bit. One of the, I want you to understand what you have to have on the top of your head and what you don't have to have on the top of your head, right? So one thing I want to point out is I do want you to be able to do this without too much problem, finding the multiplicative inverse of a number mod n. Okay, so that's what we did last time. We did a lot of that, and we're going to do a little bit more about using that today too. So you really want to be good at that, be able to go through that process. I'm not going to give you a problem that'll take a long time to do, okay? Because some of those problems we did last time, it could take a while, and I'm going to always be aware not to give you a test that takes too long to complete. So I will either give you one that has just small numbers that would be, fairly quick to do, or I might lay out the process for you and say, okay, at this point, what would you do next? Or what number goes in here? That kind of thing, kind of lead you through. I might do something like that, but I will do something to, because to make sure that you're not going to be spending, having this long problem to do that takes, most of the time for your test. Now I'm saying down here in the next paragraph, I can't really check to make sure you're not using notes. I mean, that you're using notes. And when I say notes, I actually also mean looking into the zyBook material, the actual text. Okay. So since I can't keep people from doing that, I'm not going to tell you that you can't do it. Okay. But we'll today here later, I'll hopefully narrow down those things that I want you to have on the top of your head, as opposed to those things that I plan on giving you during the test at the time of the question. So, so that you're not going to have this stuff memorized. My idea is I'm not expecting you to have lots of things memorized as far as formulas and proofs and things like that, but I want you to have the processes down of what we've done. Okay. But anyway, so I'm not going to say you can't use your notes, but you should really study as if you can't use your notes, because you don't want to have to be looking things up in your notes. You won't get done. Okay. You want to know this. And then if like, oh, one thing I wish I had, had that handy, and then you could go look that up. But if you're doing that for every problem, that's not going to be good. You won't get done. So, so as I'm saying here, don't plan on looking in your notes or in zyBooks a lot, but, I'm not going to say that you can't. One thing you might want to do is, even if we were doing this face to face, probably I would like maybe let you have like a piece of notebook. Whoops, can't see that. I'm using a virtual background here today because I'm in a different place, but I was going to hold up just a regular piece of paper. And I was going to say that if we were doing this face to face, I'd probably say, feel free to write down things that you want to remember on this piece of paper, and you can bring this piece of paper to the test and use. But of course, you know, we won't do that, but you might want to do that anyway, you know, just kind of get a piece of paper and write down some of the most important things. Because actually one of the things that does when people are able to have something like that for the test, you've narrowed down things that you know are important, and just the process of you deciding what should go on there, and then the process of you writing it down kind of helps you learn it even better anyway. So anyway, you might want to go through that anyway, just kind of write some things down, because as I said, I'm not going to keep you from looking stuff up. But it's not really necessary to do that. But if you want to do that, you can. Okay, so I'll let you come and read some of this on your own. As far as proofs go, I decided not to have you do any proofs for me. I've just found that there's so much content here, just showing me that you've learned what you're supposed to learn, that there's really no time left and no brain power left, I think, to make you have to be able to, you know, go through a formal proof for anything, except that, remember back when we were looking at like polynomial functions and showing, you know, the order of polynomial functions, and using, you know, finding a C and an N naught, so that you could show that like a polynomial that has a leading term with n to the fifth, how you could show that it's of the order n to the fifth, you know, that it's theta of n to the fifth, that kind of thing. I could have you, and I probably will have you do a little proof of that. Like, so I'll say, here's a polynomial, show me that it's of order blah blah blah, you know, and I might say something like, find the C and the N naught that would prove this, or something like that. So anyway, that's all I will do. So, you know, that you could consider maybe a proof, but it's just a matter of, you know, finding the right C and N naught, and then actually showing me, you know, start with this polynomial and it's less than or equal to this polynomial, that kind of thing. So so that's something that you would have to do. But as far as proving anything else, I'm not going to have you do that. You want to have paper and pencil handy, and you want to have even like a calculator. We're going to be using calculators today, and you'll see how I'm going to be using my computer calculator, and that's something you can use. Or if you have a scientific calculator, you know, that you want to have that use, you can do that too. So have paper and pencil handy, and have a calculator handy for the test. And so I'll let you read this other stuff here, but you definitely watch the time, because it's a timed test. You can't take a lot of time for these, you know, you just have to keep moving. So you'll need to know that. And I'll let you read everything else, other than this last thing here is make sure you have your webcam ready to go. So, you know, I said I'm going to be watching you take your test. So I'll see everybody's faces in the Zoom. So you want to pull up Zoom and have your webcam turned on as you're taking the test. And then I'll be watching to see if you've got your webcam on and you're taking the test, that's good. But if you're taking the test and your webcam's not on, then I'll try to get a hold of you some way, maybe by email, but I might have to just cut your test off, and then you can check your email to find out what happened, that kind of thing. Hopefully nothing like that'll happen, but I just want you to know, I want to really make sure that your webcam's on while you're taking the test. Now, I didn't think of this when I wrote this all down. I said, if you don't have a web, yeah, go ahead.
Sorry, I have a question about the webcam. Mine doesn't say like when I use like, okay, so my computer, like I just run it through, I don't have like a webcam or anything, but I have another computer that has a webcam, but when I log into Zoom, it doesn't show my name.
Right, okay, gotcha. That's okay. I would be okay with that. Yeah.
Okay.
That's a good point though. But yeah, I would be fine with that. Yeah. Yeah. And also, but I did think of another thing in case somebody has maybe that issue or another issue and doesn't have, you know, a computer to use. If you told me that you don't have a webcam, which is what I said to tell me if you don't, what I would probably tell you to do is see if you can use your smartphone, because what you could do is you could, you know, you don't have to be doing the Canvas test on your smartphone, but you could come into the Zoom meeting through, through the smartphone by clicking on the link from Canvas on your smartphone. And then you just have to prop your smartphone up somewhere so that it's pointing to your face or pointing to the side of your face or something while you're taking the test. Then you'd be taking the test on your computer. So, if you have an issue with your webcam, that's what you could do. So as long as I can see your face, regardless of, whether it's from your phone or your computer. But I think that'll be a little bit more awkward because you have to prop up the phone in a certain way. And so the webcam will probably be more, convenient for most people. But yeah, let me know if you don't think that, if there's going to be an issue with that, but hopefully everybody will have something going by that time. Okay. One more thing I'll say, and then I'll see if other people have questions about the test. Here at the very end of the study guide, I say, these are some things I will give you when it comes time for the test. Like maybe on that very problem, I'll show it, or I might say, open this up and have it ready as you do the test. But probably it'd be easiest for you guys if I actually show it on the problem itself. So these are the things that I would think that you might be worried about, that, oh, do I need to memorize? Remember, we had this this table here where you have all of the all these functions rated, ordered by time complexity. And if I asked you, sometimes like there's an example in the challenge activity, and it might be something like that on the test where I have you order different functions and say, order these from quickest to longest time, of complexity, that kind of thing. So I would have this available for you, although you might kind of know it already, but that's something I'd have ready for you so you don't have to go look that up. Okay. If there's any formulas like the formula for cryptography that we talked about last time. Oh, and I'll show that here to you in a minute. Those little ones, C equals blah, 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 M equals blah, blah, blah. I don't expect you to have any of that memorized at all, okay? That would also be something I would give you, okay, for if you were supposed to do that. But I do, as I said, need you to be able to understand all of these concepts we've talked about and come up with the things that you've come up with for the participation in challenge exercises, and also knowing how to do that multiplicative inverse, how to go through the entire process. But today we're going to talk about the RSA cryptography process. And this is a slide out of what we're going to start talking about. And I'm going to tell you that when, and I say when because I'm sure I'll give you a problem on what we talked about today on the test. I will actually give you this. So because there's a lot of, we're going to be talking about N's and fees and P's and Q's and E's and everything. And what we learned today, at first, we're going to be doing a lot of examples today. So by the time you're done hearing me today, hopefully it'll start making sense, and then you'll be spending time on the activities, and that'll hopefully, help even more. But because these different all these different numbers and letters and stuff like that, I figured, and this is something that we've learned just here at the end, I'm going to not expect you to remember what all of these are. I'm going to give you this. So you would have this available like on the problem itself, so you wouldn't have to go look that up either. So those would be two things I would think that everybody should, I want to give everybody as they're working on their problems, so they don't have to go look that up. And I don't know, and I don't think there's going to be really anything else that you would have to look up unless you just really don't understand something and haven't been, studying on it, I guess. I don't know. Okay, so questions on this test. Any questions at all? It will be at 4:30 normal time, but on Wednesday. So any questions?
We won't have class after the test, correct?
Right. So you'll be able to just, when you're finished, you can shut down your, get out of the Zoom meeting and And go, yes. And I said here, but I didn't talk about it yet, and you'll read it when you read this here. You will see your score right away because everything will be either short answer or multiple choice, and you'll find out how you did. But I'm not going to be letting you go in and see your responses or the correct answers until 6 o'clock that night when everyone's done with the test. Okay, so after 6, probably everybody should be done with the test by 6, but I might make it, 7 o'clock I'll probably make it 7 to be safe. So anyway, you might have to for a few hours wonder what you missed, but you'll eventually be able to get in there and see what you missed. And then of course you can write me if you don't understand why you missed something. So okay, let's see what else. Yes, what we talked about today in class will be included. Yes, that's right. Okay, other questions? Okay, if not, we will go on and start talking about RSA cryptography. Let me do this. Okay. So first of all, let's remember what we did last time. Oh, come on. Why is this not advancing? There we go. Let's remember what we did last time. So last time we talked about this symmetric key crypto system. And that was the one, remember, this was a picture of what we had last time, where we've got Alice and Bob, and they have had to agree on what n is equal to and what k is equal to. And it was important that they knew, both of them knew those values, and they had to know that before they could either encrypt or decrypt. Okay, and so see these equations in blue, in the little blue boxes. These are the types of things you wouldn't have to memorize. I would say here's the formula that they would be using. Okay, so you would have that. But the problem with this is that if Eve can intercept 3322514119, who's to say she can't intercept n equals this, k equals this, right? If however they got this information to the other person, they could have just sent the message anyway if it was really secure, and so that's where this system breaks down. How do they agree on n and k without Eve being able to find that out? So that's what's different about today, is we're going to see, is there a better way to do it so that they don't have to agree on this secretly together, and therefore have a chance of somebody eavesdropping on that information? Is there a better way that doesn't involve this prior communication? And the answer is yes, and that is called public key cryptography. Okay, so that's what we're going to talk about today, public key cryptography. Now, so here's how public key cryptography works. So Bob is going to have this encryption, this encryption key, and he's going to make it public to everyone. See this blue key? It's a public key. So he's come up with this scheme, and he's published this public key, this blue key. Anybody can use that key to encode a message, to encrypt a message. Okay, so over here, Alice has a message she wants to send Bob, so she uses the public key to encrypt it. Okay, now here Eve might get a hold of this message as it's being sent, but she doesn't have a key to unlock it. That's the red key. So everybody can encrypt a message, but nobody can decrypt a message except for Bob or anybody else who has this private key. Okay, so that's why it's very safe, because everybody can encrypt, but and so he gave this out publicly, so there's no worry, oh, somebody's going to find that out. It's like, ha ha, who cares? Everybody knows this. And yet only he needs to know the private key, so that didn't need to be transmitted, and therefore have the possibility of getting intercepted. Okay, so that's kind of how it works. Bob is the one who can unlock that message and see the answer. And we're going to be doing lots of examples, so you'll kind of see how this ends up working here as we go along. Okay, so now the most widely used public key crypto system is the RSA crypto system. That was developed by three people, and the initials of their last names is what makes up the RSA. It's Rivest or Rivest, Shamir, and Adelman. Okay, so RSA. So this is named after them, and they developed it in 1978. And that's interesting that it was developed so long ago and is being used even here today. Okay, so I see one question. Can anyone guess the private key using the public key? So that is the big question, and that's what made these guys famous, because well any public key crypto system, the hope would be that somebody couldn't guess the private key. And so this RSA system makes it's very difficult or impossible to guess. So yeah, we will talk about that, but it's hard, and that's what makes this so good, is that it's pretty much impossible. If you start, I'll have to get further into it to tell you, what you have to do to make sure that doesn't, and that it's not easy to do. But that is the genius of this system, is that it's very hard to guess. Okay, and you'll see why here in a minute.
Aren't those used for VPNs?
Probably. I don't. I'm not a network person, so I'm not really into that stuff. But probably, So, yeah. Okay. So here's why it works. Remember, last week there was a point where we were talking about factoring numbers, and we said if the number is really, really big, then there's no good algorithm that we could use that could for sure get done in our lifetimes that would be able to factor a huge number, a number that's like 100 digits long or more. Okay, so imagine a number 100 digits long or more, and you could write this brute force algorithm that would say, okay, is 2 a factor of this? Is 3 a factor? Is 4 a factor? Until you come up with, find something that's finally a factor, right? And you'll see why you need to find factors in a minute. But anyway, we said back then that when the number is very large, there's just no efficient algorithm that can be done in a decent amount of time that could come up with the factors of a very large number. So this is saying that's what this security is based upon, the assumption that it's difficult to factor large numbers. And this efficient algorithm, if there was an efficient algorithm to factor these numbers, then yes, someone could easily figure out what the the private key is, and then it would not work. So it's really good for this system that it's difficult to factor these large numbers. And obviously it's very important within the system to use very large numbers. In our examples that we do so that we can learn how this is done, we're going to use pretty small numbers just so that we can do this quickly and easily. So you'll see with the numbers we're going to use today, it would be easy for somebody to guess because we're not going to be using these large numbers. And if the number is small enough that you need to know how to factor it, yeah, you could start out, is 2 a factor, is 3 a factor, and keep going up. And if it's not that large, that brute force algorithm wouldn't take that long. So or you could just in your head try different things. So but it of course is all hinged on the fact that we're going to be using these huge numbers that would then be very difficult to factor. And right now, that's probably not making sense why factoring is involved in this, but that's because you haven't seen what we do. So we'll go into it and you'll see what we do, and it'll eventually make sense that factoring would be important in order to be able to come up with this private key. Okay, so I'm going to go through the steps that they gave in the Zai books. And then the next slide, I'm going to do it again, but kind of using different words. It just takes a while to go through and hear and see this over and over several times in order for it to really start sinking in. So I would, expect to, just sit there and stare at these steps, and it might take a while for your brain to wrap your mind around it and stuff. But anyway, so we're going to do it several times. And so this is the first time you'll see it, but as I say, I'm going to show it several more times. Okay, so first of all, how do we prepare public and private keys in RSA? So here's what we're going to do. Remember, it's Bob that's going to have all of the information. He knows the public key and the private key, and he publishes the public key. So he selects two large prime numbers, P and Q. And this is where they need to be large, they need to be prime, and he selects them. Now, that can be a feat in itself. The book talked at one point, but I think it was maybe a section that we skipped, how to come up with a very large prime number. And it's really not totally easy to do. So that could be a problem in itself, especially if you want a large prime number that's got hundreds of digits. But I would guess that there's a list, and you're not going to have to come up with, when you do this, you're going to be given, when we do this, you're going to be given a P and a Q, okay? Or if you were going to do this as an example, you could pick a P and a Q that aren't that big. But, in reality, if you were really trying to encrypt something, you would need something big. And anyway, my point is that I would guess that somewhere there's a fairly lengthy list of large prime numbers. So, published somewhere that it's been proven that these are prime numbers. And so, therefore, if you were really looking for prime numbers, you could go out and find a couple. And if there's enough of them published, it wouldn't be a problem to just pick out of there, because not everybody would always be choosing the same ones. But anyway, choose two large prime numbers. Then he's going to take those numbers, P and Q, that he's chosen and multiply them together to get N, okay? Capital N is equal to P times Q, okay? That's all it is, just multiply those together. Now there's also a value we're going to call phi. This is the Greek symbol phi. Some people call it phi, but I've always heard it as phi, and it's better as phi because then we get a lot of rhyming going on today in our things that we are talking about. It's kind of nice to have the little rhyme going. So anyway, so I call it phi. So what is phi? How do we get phi? Well, we subtract 1 from each of those numbers P and Q and multiply those together, okay? So from those two prime numbers P and Q, Bob now has capital N and then phi, okay? Two different numbers. Now, Bob has to find an integer E such that the GCD of E and phi, see what I mean with rhyming? The GCD of E and phi is equal to 1, meaning that E and phi should be relatively prime. Okay, that's what, if their GCD is 1, that means they're relatively prime. And that could be an issue too, but that would be something that maybe isn't quite as hard, because you could just guess a number and then try to find the GCD, using our little method that we do where we have numbers lined up on one row and keep going down and down and down until we find the GCD. So that wouldn't be as hard. Just choose a number, and chances are that number will be relatively prime with phi. But if it's not, then you just kind of keep picking until you find one. Now, for your examples on anything that you do or for the test, you're not going to have to come up with E either. You'll be given P, Q, and E. Okay, so that'll be something you're given. So you don't have to worry about coming up with it, but just know how E is found. It's got to be some integer such that it's relatively prime with phi. Now, here's where this multiplicative inverse comes in. Bob then computes the multiplicative inverse of E mod phi. Okay, so that's something, you know, I want you to know how to do. We did that last time, finding that multiplicative inverse, and we'll be doing it again here today. So you'll see it done again. But that is something I would want you to be prepared to do and show me in class, or at least show me, you know, like I said, I might give you parts of it and tell you ask you what comes next or something like that. But if it's the multiplicative inverse of E mod phi, that means that if we multiply E and D together and then take mod phi, we get 1. I don't know that last part helps much. It's true. But you probably don't have to remember that. Just you know, just know you got to get the multiplicative inverse of E mod phi. Now, you know, and like I said, you've done a lot of that before, so hopefully that wouldn't be an issue, wouldn't be a problem. Now, so once we get all of these different values, all the public key is just publishing what the value of N is and what the value of E is. Okay, so they say, hey, if anybody wants to send me an encrypted message, I'm using RSA and I'm saying that N is equal to blah, 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 and E is equal to blah, blah, blah. And that's all a person would need. And then, okay, I'll show something else to show up here in a minute. But let me tell you why. Here's now where the factoring issue comes in, okay? Remember, N is not P and Q. N is multiplying P and Q together, multiplying these very large prime numbers together. And see, that's why it's so hard to be able to come up with the secret key, the private key, if somebody just knows the public key, because they don't know P and Q, they only know N. And in order for them to come up with P and Q, they would need to be able to factor N. And N would be this huge number with hundreds of digits. And that's where that's why this idea that we can't come up with an efficient algorithm to factor some large number like this, that's why that helps us in this RSA system, because everybody knows N, and that's all they need in order to encrypt the message. But in order for them to decrypt it, they need the private key, which is just this D, which is the multiplicative inverse. Oh, I didn't say that here, but we're going to call it D. For step 4, this multiplicative inverse, we're going to call it D. So now the way somebody could try to guess is all they know is N and E. They could try to factor in, and if they come up with a couple of factors, they could go through this whole process and try to find find the multiplicative inverse, and see if they used the D they come up with, if the message made sense. We don't know, maybe N has more than one way to be factored. So that would be the other thing, is they could come up with one set of factors and then find D and then see if everything made sense. But maybe they would choose the wrong set of factors. Maybe there's more than one way to factor N. And so maybe they would choose the wrong ones and then get a D, but that doesn't help them because they get a message that doesn't make sense. So does this make sense so far, what I'm saying? Does everybody kind of see why the fact that it's hard to factor a very large number would make this work so well? Okay. I do want to say this here too. These are the formulas that we'll use with RSA, that are used with any RSA system, okay? Now, it's not the same as what we used last time, where they were doing, agreeing on an N and a K beforehand. So that was a set of equations that I said you didn't have to memorize. And this is a set of equations that I'm saying you don't have to memorize. I will give you this, okay? But notice that if somebody wanted to encrypt a message, all they know is N and E. So they can go into this equation here. Remember, M stands for the plain text, which is something they can get to, using that alphabet trick. And they can take it to the eth power mod n, and they get the ciphertext that they send on. And then only the person who knows D can do this one. And they take C, whatever they got for the ciphertext, to the Dth power, and then mod n, and then they get the plain text. And then they could find out what the message is from there. Okay, so those are what are used in order to go back and forth between plain text and ciphertext. Okay, any questions at this point? Okay, if not, I'm going to go through this again. We'll just do it again. I'm just going to make it look a little different, use a few different words, but it's just the same thing. But just to kind of get it in your mind what we do. So, let's say you're Bob and you want to come up with this system. So you're going to pick two large prime numbers, P and Q. And then you find N. You multiply P and Q together. Then you find phi, which is P minus 1 times Q minus 1. Now you're going to find an integer E such that E and phi are relatively prime. And here on this screen, I kind of said what you can do. Just choose something that's possible. I didn't say this, but it's going to be, E is going to be less than phi. But anyway, you're just going to choose some E such that E and phi are relatively prime. So it just choose a possible one and then check to see. If the GCD of E and phi is equal to 1, then you know they're relatively prime, right? And so you could always go through that process and find that. So you would hope to find that. And then if the first E you chose does not have this to be the case, then keep guessing until you find one. Since phi is really big, there, it's probably a fairly good chance whatever you come up with is going to be relatively prime. Well, I guess I shouldn't say that, but anyway, we're not going to have to worry about it, like I said, because you're always going to be given what E is. So don't have to worry about that. But this is the process that you'd have to do if you were doing this yourself. Okay, now the next step would be to find D. And D we get by finding the multiplicative inverse of E mod phi. And that, again, is that long process we did last time, where you write all these numbers in a long line. You keep going to the right until you get down to 0, and then you back up 1, and then that's the GCD of those two numbers. And then you have to start using those equations to then eventually come up with, remember that's the GCD equals then some linear combination of your two original. Anyway, I'm getting into that whole process, but hopefully this is sounding familiar to you. This is what we've been doing. Okay, so you would go through all of that. Once you find that multiplicative inverse, you're going to call it D. So then the public key would be, you would send out what N and E is, and then anyone can do this, can use this equation to convert any plain text into ciphertext. Okay, because all it needs is N and E, and they would come up with the M, right? M is the plain text. Then the private key is just knowing the D, and then knowing D, you can come up with the plain text using that equation. And again, so the reason why it's so hard for someone to break this is that the only way they're going to be able to find D is to be able to guess what P and Q were, or somehow factor in and come up with P and Q. And that's why it's so hard, because if these are large numbers, it would take too long to come up with that. Okay. So hopefully it's starting to sink in, but I understand with all these new symbols, it's going to take a while, and you're going to want to do all of your assignment and get lots of practice that way too. Okay, so here's one more picture, and then we're going to do an example. But I think I took this, I took this off of ZyBooks. So we've got Bob, who has come up with a system where N is equal to 1829 and E is 859. So he makes that public. So then he knows that D is equal to 79. no, here it's not told us what P and Q is, but we would know that he knew originally what P and Q were, and so he was able to find D. Okay, so then Alice wants to send a message, and the plain text is 1211. So she goes up to the public key and she uses N and E and uses this formula. Again, this would be a formula you don't have to memorize. I would give it to you. And so she would come up with C. So this is how the book did it. So that's why the book used that capital C, which is a little weird. It should be a small c, just because you might wonder, why is it small in one place and capital in another? I think it's just a typo. So anyway, how did she get C? She used M to the E mod N. We're going to do some examples and you'll see how easy it is to do with a calculator. You might think, how can I take 1211 to the 859th power? Surely that's not going to be easy to do, but with a calculator, we can do it real easily. And so anyway, we can get this. Then, so she would send the 388 to Bob. And then Bob knows D, so he's going to use D in start with C, take into the Dth power, and so on. And then he'd be able to find M. So he finds that M is equal to 1211, which is what she wanted to send. Okay. And all along, I don't think I have a picture of Eve in here. Yeah, I don't have a picture of Eve, but obviously, if she gets 388, the only way she could break this would be looking at N and saying, how can I factor this? Now, 1829, we use small numbers. This wouldn't take very long for someone to come up with P and Q, given that N is only 1829, right? So with these small numbers, it wouldn't be hard to find P and Q. And remember, there might be more than one set of factors, but she could, anybody could just kind of try to find a set of factors and then try to find a D and then use D to decrypt and see if it makes sense. And if not, they might say, well, let me find another set of factors of N that I could use. So it would be possible here, but not when it's done and using many digits. Okay. I'll assume there's no questions, but now we're going to work some problems together. I've got my tablet and I'll write this out. I don't know if you want to write along with me, or at least just, and you'll have these notes I'll have available on Canvas, so you can look back at this, okay, later. But this is the kind of thing you would need to do for your participation activities today, for this week, and your challenge activities. And even though I don't have these due until next Monday, which is what I usually do, give you till the next Monday to do them, you're going to need to know how to do this by the test on Wednesday. So I would say definitely try to get them done before Wednesday, or at least make sure you really know how to do this, because I'm sure you'll have to do something like this on the test. Okay, so we're going to say, suppose that Alice and Bob are using RSA, and Bob selects P as 7, Q as 17. So we're going to use these small numbers. Okay, so first of all, what's the value of N? So let's work this together. N is going to equal P times Q. So it's 7 times 17, which equals 119. I won't take the time to pull up the calculator until we get to some harder stuff, and I'm going to pull the calculator up just so you can see how easily it can be done. What's the value of phi? Now, they used a different symbol for this phi. I took this straight out off of, not the actual, I changed the numbers here, but I took this straight out of the text, straight out of their participation activity. So they used it. This is also phi. It looks a little different than the phi we saw a minute ago. It's just a different way to write it. So they just use it that way. So it's a little easier to write that. I might write it here using that. I don't know. But okay, so what is phi? Well, so phi is equal to P minus 1, which is 6, times Q minus 1, which is 16. So we're just subtracting 1 from the P and the Q and we end up with 96. Now, then the next part is if E is chosen to be 19, what is D? Okay, so usually when I'm at this point here, I'm trying to remember now, what is D? What do I need to do? Well, D is the multiplicative inverse of E mod phi. Okay, so you know how, and E, let's see, E is 19 and phi is 96. So the question is, how would you go about finding the multiplicative inverse of 19 mod 96? Well, you know how to do that because that's just what we did last time. So remember, the way you do it is start with the two numbers. So these are our two original numbers, 19 and 96. We're going to start, we always start with the highest one first. So 96 goes first, and then 19 comes next, okay? And then the next one is going to be, we start taking the mod of the largest, you know, we take the largest number mod the smallest number. So we're going to have 96 mod 19, okay? So you can look that up on your calculator. Now, let me, I have to have this full screen in order for my tablet to work, but I can't show you because I'm not using, sorry, I'm not using my normal setup since I'm I'm not down in my basement because it's very cold down there. So I only have one screen. So it's going to be a little harder. So I have to stop this so I can show you the calculator. Now I have this calculator app on my computer. If I first pulled it up, you know, I probably searched down here and looked calculator, and it was probably there for me. I don't know. You can always, you know, use a online calculator even, where you would do something like online calculator and get something like this. Now you do want one that is that's going to have a mod button. This one doesn't see, I don't see a mod button here. And you might think, well, I can always do the mods myself, but you won't be able to when the numbers get big. So but here's a scientific calculator.
If you just,
what's that?
if you just Google
right,
if you just Google it, there's like the first one should.
Yeah, well, so like I Googled online calculator, and my first one, this one here that came up didn't have mod. But yeah, if you Google scientific calculator, you should get mod. So, well, wait, that's Desmos. Okay, so you're saying use the word mod in there.
Yeah, type in modulo or mod. I guess it looks, I've always thought it was mod. Yeah.
Modulo calculator. Yeah. And really all you need is, and like I said, my calculator that I already had, you know, it might show up as just standard like this. And then you don't see the mod, but you can change it to scientific, and then usually the mod shows up. So I've never really needed to do this online calculator, but I was just showing you since you know, in case you can't find this. Now, if you actually have a scientific calculator like a TI 89 or something like that, feel free to use that too. But anyway, you're going to need this for the assignment, and definitely have it ready for when it's time for the test, because you'll need to be able to just know where to go and be able to get that. But yeah, so if you can't find it this way, find some application that's already on your computer, or one that you can install on your computer, then yeah, online calculator, say mod, and then this. And I saw it here, somebody also said mod with exponents, and you need to be able to do exponents too. And what you need for that is this button, X to the Y. Anyway, those are two buttons we need for this, and we'll be using them here, so you'll see it. But anyway, hopefully you'll find one that works, and maybe you already have it on your computer. Okay, so I will show you here what we would do here for 96 mod 19, and we get 1, okay? And you might think, wait a minute, really? 1? Yes, this is a nice, easy problem. We get 1 right away, okay? So we are gonna, and okay, so we'll go ahead and continue on, but we do end up getting 96 mod 19 is equal to 1. And then we go on, and the next one is 19 mod 1 is 0. And that's what we're always going to find. We're always going to get down to 0. And if they were multiplicative inverses, which they should be, because that's how you chose E, then you'll get 1 eventually, and that's, you know, right before you get the 0. This one was nice because it came quickly. So we're not going to have a lot to do in our with all of our substitution stuff here today, but for this one. But anyway, so remember, once you get down to 0, you step back 1 and you say, this is my GCD, okay? So if this is my GCD, remember the next step in order to find this multiplicative inverse is we need to write the GCD, which is 1, as a linear combination of those original 2 numbers. So we need to be able to do this. 1 equals something times 96 plus something times 19. And then once we find this, we're almost there, but then we need to figure out which one to pick up and then take a mod of it. And then we're almost done, right? So that's that whole process you've done before. So let's go ahead and start that process of writing equations now. So now you remember we start with this 1, and then remember we use the 2 previous numbers here. So we have used 96 and 19, and we use that pattern. So remember that pattern. And this is a pattern, you might know it now by now, but if you don't, then that might be something you might want to write down on a piece of paper so you'll have it handy when you need it for the test. But remember, it's 96, the largest one, minus the largest one div the smallest one times the smallest one. And remember, we're going to leave 96 and 19 like they are, but we are going to evaluate this div here. So I'm going to say 1 equals 96 minus, now to find the div, there's not usually a div button on a calculator, but you can just take 96 divided by 19 and you'll get a number, right? And then whatever that number is, well, let me do it real quick here. Okay, so you can say 96, I didn't mean to pull up Greenfoot. Okay, start again here. 96 divided by 19. And see how we get 5 point blah, blah, blah. Well, the div value would be what comes before this, the decimal, okay? Because you're finding how many times does 19 go into 96, and we know there might be a remainder, okay? So that's how I would get the div. Just divide it and then take what's in front of the decimal, okay? So we get 5 here times 19. Okay, now normally when we do this, we would need to keep going and have some more equations, but this is what's so wonderful about this example. We already have one written as a linear combination of the original numbers because we didn't have to go far to get 1. And so remember how usually then you go to the next one and write it as a, use the pattern again and keep doing it and then having to substitute. But we've already gotten to where we want to be right here. We've got 1 written as a linear combination of 96 and 19. So if we really wanted to write it just like I have it over on the right, I say 1 times 96, and then, you know, plus, if you want to do it that way, minus 5 times 19. So we found these things here. Remember, we called them S and T before. And we need one of those in order to find this multiplicative inverse. And the challenge is always to know which one to use, okay? Now, the way I think about it right now, in this context, is I look up to see which one was the modulus. I mean, so which one we're taking the mod. We're mod of what? We're taking the mod of what? We're taking the mod of 96, right? That's why it helps to have this written down ahead of time. You can go back up there. What are we taking the mod of? We're taking the mod of 96. So see 96 here? We don't want the number in front of that one. We want this other number right here, the number in front of the one that's not the mod, because that's the one that's not the one that we're taking, you know, not the one that we're taking. It's the one we're taking the mod of, but you know what I'm trying to say. We're taking E mod phi, and so we don't want what's in front of the phi. We want what's in front of the other one, which is E. Okay, so that would be this -5. So -5 is not our D yet, right? But remember, if we call these S and T, there was one more step where we called it like SN, or something like that. We went on and did that. But in this context, it's going to be, we don't necessarily have to call it S and T, but you're going to take that one that's not in front of phi, but in front of the one called E, and take it. So D is going to equal what that number is, and then we take the mod again, mod phi. Okay, so this mod that we're looking at this whole time, we're going to do that before we actually get D. And we do have to do that mod step. If you look back in the process that we were doing last time, you see that's what we do at the end, is take that mod at the end. Okay, so -5 mod 96 ends up being 91. Okay, so now we have all of these different values. So D is equal to 91. Now we'll go on to the next questions. So this is the same problem. Let's just, since we've kind of lost what's on the slide previous, I'm going to remind us here what the values are. So N was 119, phi was 96, E was 19, and D we found to be 91. So then it says, if Bob receives a ciphertext C equals 23, then what was Alice's plain text M? Okay, so this is where you use one or the other of these blue boxes. Okay, we already know C, we're trying to find M, right? So since we're trying to find M, we're going to use this one right here. So we'll say M is equal to C, which is the 23, to the power of D, so to the power of 91, mod N, and N is 119. Okay, now again, like, you're not going to try to do 23 to the 91st power in your head, and then you're going to, whatever number you get, it would be big enough that you don't even want to try to do mod 119 in your head, or, you know, even on paper without a calculator. So here's where, again, you want to have a calculator handy. So I'm going to show you here with my calculator how we would do this. So you want to have a calculator not only that has the mod button, but also has this X to the Y, because that's how we find 23 to the 91st power. So here's what you do. You start with 23, and then you click on the X to the Y. That's saying, now I'm going to give you another number, and I want you to take 23 to that power. That's what this is saying. So you click on that. So notice it has 23 in this caret, which means to the power of, and then I say 91. And I don't need to find it. I'm just going to go ahead and say mod 119. And I get a number, and that's great. That's all I need. I'll just, that is the right number, so we'll just use it. Okay, so just really, you'll be using a calculator like that for a lot here for the assignment and then eventually for the test too. Okay, so we found that that equals 107. So so that's what M is. So the original plain text was 107. And so, they would go use that alphabet trick, which probably doesn't end up even saying anything, A, and then one of the other letters in the alphabet early on, the 7th letter, that's not even going to say anything, but we're just staying with small letters. I mean, small numbers. So that wouldn't, that's why this doesn't really say anything when you go change it back to the alphabet. Okay, so now the next one is if, the plain text that's starting out is 12, what would the ciphertext be? So now we're going to use this other equation. So we say C is equal to M, and M is going to be 12 to the eth power, and E is 19. So 12 to the 19 mod, and again, which is 119. And so again, we would go to the calculator and do that same thing. 12, and then hit the X to the Y button, and then put in a 19, and then mod 119. And we get 12. Oh, whoops, wait, not 12. That's what, oh, I was looking at my check. We get 96. Now, if you have time and you're just, I'm always, I always want to just double check, make sure I didn't make any little mistakes. So, you can do some checking by now taking 96 and converting it using this other equation, other formula here, and see if you get 12 back, right? And that's why I picked up 12 here. Is on my paper I had equals 12, but I was looking on the part that I was checking. And you probably don't necessarily have time to do checking during the test, unfortunately, but if you feel like you have time, all the better. It is really good if you can, but anyway, that's why I picked that number up. Okay, any questions on this problem? Okay, if not, we'll go do one more here real quick. I think we have time, or we might rush through it. I have just a couple more slides to mention, but here it's starting again with Bob selects P and Q. So we have 17 and Q, 17 and 11. So N, of course, now is going to be 17 times 11, which is equal to 187. Value of phi is going to be 16 times 10, which is 160. Now, E is going to be chosen to be 3, so we want to find out what D is. Okay, so we need to find multiplicative inverse of E mod phi, which is E is 3, phi is 160. Okay, so we know what to do. We've got two numbers, 3 and 160. So we'll start with 160, 3. Up here we have 160 mod 3, and that ends up equaling 1 again. Okay, so that was very quick. And then again, the next one would be the previous two, 3 mod 1, which would give us 0. So we back up 1 and say that's the GCD, and that's what we would hope, because E is supposed to be chosen so that the GCD is 1. Okay, now let's write out our equation. We're looking for 1 is equal to something times 160 plus something times 3. So we'll start with 1 equals, and we'll use that pattern, the largest number minus, and then in parentheses, the largest number div 3 times 3. And what's inside the parentheses ends up equaling 53. So we have our numbers here. This is going to be, I'll just go ahead and write 1 times 160 minus 53 times 3. So we got a 1 in here, and a negative 53 here. Okay, now again, we're going to take one of these numbers and then take a mod, and then we found D. The question is, which of these numbers do we choose? Which of these numbers do I choose? Sorry, trying to get off of the eraser. I just made that one look funny before. Okay. So the question is, which one? Okay, remember again, you wanted the one in front of E, not phi, right? So look, find E is 3. So we're going to want to pick up that number, the negative 53, not the 1, okay? So D is equal to, we start out with that number, but remember that's not D, but we then have to take mod phi. So it would be mod, we take the coefficient of the 3 and then take mod of the other number, which is 160. Okay, and this, you just have to do this a few times to really make so that this makes sense as far as knowing which one to pick up and so on. Okay, so that ends up being 107, which is funny because we had 107 as a different number in our previous problem, but that was in a different context. So anyway, it just happens that we got another 107 again. And so that would be our D. And then the last thing real quick, this one I didn't ask to convert plain text to ciphertext and back, but I said, what's the public key? Okay, so the public key would be N is equal to 187 and E is equal to 3. That's what you would give out for the public key, and anyone could encrypt a code that way. And then for the private key, you need to know D, which is equal to 107. So that is another example. Any questions on that one? Okay, if not, and I'm sorry I didn't wait too long on that, but I'm assuming somebody would have jumped in by then, but just trying to finish this up because I know I'm about out of time. But I just wanted to say that there's one of the things that they have you do in the challenge activity is sometimes they ask you which of the following is the correct choice for D. See, they give you P, Q, and E, and they say which is the best. I mean, which is the correct choice for D. Now, you could go through that entire process like we just did. Maybe it'd be an easy example where you get that answer pretty quick. Maybe you'd have several equations that you have to go through and do some substitutions. But one quick way to do this, and you might have thought of this, is you can just check each of these to see which of these times E mod phi gives you 1, because that's the definition of multiplicative inverse. So you just take each one of these times E times 29, and then take mod, and then you got to find phi. Anyway, I don't know. You would have already found phi, so that would have been something you probably already had. So there's that little shortcut where you can just kind of stick all of these in there and find the one that works for this if you want. Otherwise, you can go through the long process too. Okay, and one last thing is I did give you another, I think you'll get plenty of practice with the assignments, but sometimes, there's always these additional exercises at the end of the Xi books. And I don't usually, sign them, but I thought if you want some more practice, I went ahead and said, go ahead and work on this one. And I gave you the answers down here. So, and I might have, I don't know if I rephrased any of that, maybe not, but I just gave you these answers here. So you could go ahead and do this one too, and then check your answer and see what you get. So you might want to do that if you have time. And that is it for today. So I will post those, I'll post those notes here real quick. And then I will let you guys study and work on those and see how you do. Stick around if you do have questions and I can help you for a bit. Or if you have questions as you get to working on them and you get confused, definitely let me know and I'll be watching my email and getting back with you. So anyway, okay, I'll let you go since we're past time, but definitely stick around if you have time and have a question. Otherwise, see you on Wednesday for the test.
So, real quick question. This is on the